Hey, it's Dr. J. 5.3 today, decimals and fractions. So let's just get right at it. We're going to kind of combine the concepts of decimals and fractions. My goal here with this lesson is so that you have a good understanding not only of decimals and fractions, but how they interrelate with each other. And ultimately, especially moving forward for the rest of this semester, some problems might be presented in decimal form, others in fraction form, and really, it's what I call tomato, so that you are familiar and well acquainted with both. Now, let's start off with the fractions with a denominator of a power of 10. So if you have use the word rewrite. I guess I'll say rewrite. Yeah. Rewrite or write or convert each fraction into a decimal. So you won't need a calculator or anything for any of this. This can all be done by what we call inspection. So you just look at it, you read it, and then you convert it into a decimal. Now, if the denominator is a power of 10, so 10, 100, 1,000, 10,000, etc., then you can literally write it as a decimal simply by reading the fraction. So this means 54 tenths. So we're going to find the tenths space. Let me just write it out as if we don't know the answer right away. I probably won't do this for every problem, but I'll start off by doing this, example 1. So we have whole to the left of the decimal, tenth, hundredth, it's technically tenths, hundredths, and then thousandths. I don't think we'll need the hundreds or the thousandths in this example. So look for which place you are in. So you are in the tenths place. And then put the last digit in the numerator in the tenths place. So the 4 goes in the tenths place. And then the 5 goes in the whole place. So there you go. 54 tenths. You would write this as 5.4. Of course, you don't need the lines, and you may omit any of the places that we did not use. So again, suppose I have 3 tenths. Well, find the tenths place. Again, you can just, it's the first digit passed to the right of the decimal point. And since this is a single digit, it's just 3. That is 3 tenths. There is no whole part. And so that would be 3 tenths, 0.3. So this is the technique for rewriting a fraction as a decimal, provided that the denominator is a power of 10. Let's do some higher powers. You could say write, you can say rewrite. Write each fraction as a decimal. And let's do some higher powers like hundreds, maybe thousandths. I said hundreds. I should have said hundredths. I know. We'll do thousandths. Oh, that's thousandths, 3 zeros. And I guess we'll go to 10 thousandths. Now, the most common mistake that I personally would make when I was, learning decimals and fractions many, many years ago is I would read it 98 hundredths. My brain would memorize the different decimal places. Okay, and I know that this is hundredths. Okay, so if that's hundredths, when I was, an amateur at this, and many of you might be, be able to relate to this, you read 98 hundredths and then you write 98 right here in the hundredth spot. That's not the way it works. It's 98 hundredths, so that means the 8 goes in the hundredth spot. Not the 98, not the 9, the 8 goes in the hundredth spot. Then the 9 would actually go in the 10th spot. Now, I know it's kind of a stretch, and I'm not really going to write it this way, but the 9 actually means 9/10, and the 8 means 8 hundredths. So it's 9/10 and 8 hundredths, but we don't call it that. We just call it 98 hundredths, right? Because remember what 90 is, right? It's 9 times 10, so it's 98 hundredths. And then if there is no whole part, put a 0. And again, I don't need these lines here. So there you go, 0.98. Okay, same technique here. So you got 72 thousandths. So whole, tenth, hundredth, thousandth. Okay. And make sure you put the 2 goes in the thousandths place, 72 thousandths. It's always the last digit in the numerator goes in the position determined by the denominator. And then the 7, and then any empty spaces, fill them with zeros. And finally, 10 thousandths, so whole, tenth, hundredth, thousandth, 10 thousandth. The last digit is a 2. Hope you can read that. That's 10 thousandths. So we're going to put the 2 in the 10 thousandths place, and then the 5 and the 1, 152 10 thousandths, and then fill these up with zeros. And there you go. Now, they're not all going to be this easy because not every fraction has a denominator that's a power of 10. But if it does, if you see a denominator that's a power of 10, then that means you have almost an instant answer. Of course, you do have to read it. It's not quite that instant, but there's not a lot of scratch work. I'm not calculating anything. I'm just reading and writing, reading and writing. Example 3. Write each fraction as a decimal. I might as well just leave this instruction up for a while. The next example, I'm going to do some fractions that you probably see all the time, or you at least hear them all the time. I'm not exactly sure how often you see them, but you hear them quite often. These are very common fractions that appear in the world. And there's many more. These are just the ones that come to mind when I think of common fractions. While I'm waiting for my camera to come back to me. Come back to me. So 1/5, 1/4, 1/2, and 3/4 while we're waiting for the camera to focus. Come on. Come on, come on down. Come on down. Come on. Just be patient. It's fine. It's going to focus. Or maybe it's not going to focus. I don't know. There we go. I had to trick it. So I actually recommend two different techniques for these. Notice these are not powers of 10. Yeah, these are not powers of 10. So there are several different techniques. One technique is you could make this into a power of 10. Yeah. So you would ask yourself, what is the smallest power of 10 in which 5 goes into? And it's not really a trick question. It's 10, right? 5 goes into 10. So how many times does 5 go into 10? 5 goes into 10 2 times. So you are going to multiply the numerator and denominator by 2 because you're sort of forcing the denominator to be a power of 10. And then now the numerator becomes 2. So this is an algebraic technique that you'll use quite a bit in intermediate and college algebra, where you're taking something that's not what you want it to be, and then you're forcing the denominator to become whatever denominator we choose. In this case, we're choosing 10. Okay. So that's one technique. Notice now, once you have it as a power of 10, now you can just read it 2 tenths, 2 tenths. That's one way to do it. The other way to do it is just to memorize, because you see this all the time. 1/5, yeah, 1/5, 1 out of 5, yeah, 20 cents. Yeah, there are 5, 20 cents in a dollar, and you spend money all the time. So whenever you see 20 cents, that's what that means, 20 cents. I know there's an invisible 0 over here that I'm not writing unless I'm doing a word problem, but that's 20 cents. So you can just memorize 1/5 is 20 cents, or 2 tenths. Yeah, 2 dimes, yeah, 20 cents. That's what a dime is. A dime is a tenth. Okay. And then there's a third method, which is just to use long division. So let me say what I mean here. If you cannot memorize it, or if you just don't remember it, if you don't think to multiply it by 2, and those two things just don't happen, then you can always use the old trusty long division that we keep around. In fact, we never really get rid of long division in math. You can just go back to the original problem, 1/5, put the 5 on the outside, that's your divisor. Your dividend is 1. And then you just ask yourself, how many times does 5 go into 1? 0 times. Put a decimal. How many times does 5 go into 10? 2 times. 2 times 5 is exactly 10, remainder 0, and there you have it. Okay. So you've got lots of different methods. It's your choice. And choose whichever method you like. All right. Let's try them with 1/4. All right. 1/4 is also called a quarter. That's how it got its name, right? A quarter, yeah. 1/4, 1 out of 4. And what monetary amount, how much money is a quarter? 25 cents. And again, that's if you just have it memorized. It's always nice to know that you already know it. Yeah? A quarter is 25 cents. Okay. Or if you didn't have it memorized, you could do this trick like we did over here, multiplying it to force the denominator to become a power of 10. Now here's the problem with this one. 4 doesn't go into 10. 4 does not go into 10 without a remainder. So what's the next power of 10 that 4 goes into? 100, right? It doesn't go into 10, but it does go into 100. So we would multiply this by 25, and this would force the denominator to become 100. Yeah, 4 times 25 is 100. Now it's a power of 10. Once it's a power of 10, 1 times 25 is 25, and there you have it again, 0.20, let me just put it under here, 0.25 or 25 1/100ths. Okay, and then worst case scenario, I'm just going to keep this as my long division spot in case I need it. You can use long division. This is kind of the old faithful method here. Just remember who goes where. The denominator is the divisor. It goes on the outside. The numerator goes on the inside. Okay, 4 does not go into 1. 4 goes into 10 2 times. 2 times 4 is 8. Remainder 2. And then bring down a 0. 4 goes into 25 times. 5 times 4 is 20. And then stop when you get a terminating remainder of 0. So either way, a quarter, 25 cents. A quarter, 25 out of 100, 25 cents, or 0.25. Or 4 goes into 1, 0.25 times. All right. Now, you might not want 3 different methods, right? You might sit there and go, I just want one way to do it and get the right answer so I can pass the test. Well, then pick. Your choice. If you don't want 3 methods, then don't do 3 methods. I like having 3 methods because if one method escapes me or if I just didn't memorize it, then I always have my old trusty, faithful long division over here that always works. All right. How about this one? A half. You probably have this memorized since you were a little kid, right? A half is 0.5. 50 cents. Yeah. 5 out of 10. Yeah, you like that method better? I do. 2 does go into 10. 2 goes into 10 5 times, so I can multiply by 5, and I get 5 out of 10, which is still 0.5. Okay. Either way. Now I'll leave it to you as a DIY. Try the long division. Put 2 on the outside as the divisor. Put 1 on the inside. Do this same division algorithm here, and you'll get 0.5. Okay. And then finally, 3/4, 3/4, also known as 3/4. You probably also have that memorized. That's 75 cents. Right? Just like when you're a little kid and you have 3/4 in your hand, 3 25-cent pieces, 3/4, that's 75 cents. And again, if necessary, you can do the long division. You could do it like this. I'll do this one for you. 4 goes into 3, 0 times. 4 goes into 30, 7 times. 7 times 4 is 28. Subtract remainder 2. And then 4 goes into 25 times. 5 times 4 is 20. Remainder 0. So either way. Now, once you've learned these methods, now you can apply these methods to any fraction that you see in math or in life even. You see a fraction and you prefer to look at it as a decimal because, I know that most people are much more familiar with the way decimals appear in terms of quantity in their mind and what that actually represents. So feel free to pick and choose the methods that suit your ability as well as your understanding of what a number is, Okay, so that's about the introduction to this section. Now I'm just going to go through and practice these principles. So let's do write 7/2 as a decimal. Now, why don't I just call this A, because I'm probably going to do several of these. 7/2. 7/2. Long division works very well for this, unless you have it memorized. This is not one of the traditional ones that you have memorized, but I think maybe throughout your college education, you're going to take enough math that you'll probably will end up memorizing this one anyway. The main thing is remembering who goes where. The denominator is the divisor. The numerator is the dividend. So 2 goes into 7 3 times. 3 times 2 is 6. Remainder 1. Put a decimal point. Remember, decimal point goes straight up. Bring down a 0. 2 goes into 10 5 times. So it equals 3.5. Right, 5/4 is a decimal. Now here's one thing I really hope that you do. Guess. All right. 5/4, also known as 5/4, also known as 5 25-cent pieces. So that's $1.25, right? So $1.25. So that's your guess. You already think you're going to get $1.25. Well, let's go ahead and do it. All right. 4 goes into 5 one time. 1 times 4 is 4. Subtract, remainder 1. Put a decimal. Bring down the 0. Notice how the division algorithm, it just repeats the same steps over and over again. 4 goes into 10 2 times. 2 times 4 is 8. Subtract. Bring down another 0. Divide again. 4 goes into 20. 5 times. It's starting to look exactly like $1.25. 5 times 4 is 20. Subtract. Remainder 0. Don't stop until you get a 0 remainder. Let's see if I got room for one more here. Instead of 5/4, let's do 4/5. We're not going to be using mixed numbers in this section, so I'm not going to be writing 5/4 as 1 1/4, but you certainly can think of it that way, but just don't write it that way. Write it as a simplified fraction. Oh, I forgot to put my answer here. It's over here, but let me just complete that one. And so now I'm doing 4/5. Okay. Now, again, there's a couple different ways of thinking about it. A fifth is 20 cents. Yeah, 20 cents. So if you have 4 20 centses, now I know we don't have a coin that's 20 cents anymore, but we have dimes. So that would be, how many dimes is that? 8 dimes. Yeah. 4/5 would be 8, the same as 8/10. So you could think about it practically, like in a tactile way, if you were actually holding this change in your hand. Maybe you don't use change, right? Maybe you just don't even think about the change when you spend money. Well, then just use your division process here. Division algorithm. Okay? I'm getting real tight on space here, so I'm going to put it right here. So I've got, cordon that off a little bit. So 4 is the dividend. 5 is the divisor. 5 does not go into 4, so 0 times. Make sure you put the 0 above the 4 and then bring your decimal point straight up. 5 goes into 40 exactly 8 times. 8 times 5 is 40, remainder 0. So this is equal to 0.8 or 8/10. All right. And there's lots of other fractions, right? There's 8ths and 16ths and thirds and sixths and things like that. We're going to get more into the really, I don't want to use the word complicated, but that was the first thing that came to my head. The more complicated decimals later in this lesson. All right, we're just getting warmed up here. A lot of this is conceptual, so I hope that you're not just memorizing a process, but that you have a conceptual understanding of what it is that we're actually doing. It'll go a lot farther than simply knowing the right answer. One way to build a good map in your mind, I always think of mathematical operations and mathematical processes like maps, and you want to be able to go from one place to another, like on a map in your mind, and then you want to be able to go back, right, the other way. So, of course, I want you to be able to write a decimal as a fraction. You don't want to have a one-way road that you can't go back on. You want to be able to go both ways with it. So 0.125. Let's do a couple of these. How about 1.4? How about 2.2? I think I could squeeze in one more down here. 0.85. All right. Now, again, I mentioned this earlier, no mixed numbers. So when I say fraction, I mean it could be proper or improper. No mixed. Right. That's because I'm saying a fraction. So it has to be a singular fraction. All right. So 0.125. I think I mentioned this at the very beginning of chapter 5 when I said when you read it that way, it does not help your brain one single bit. Because saying 0.125 doesn't tell you what this actually means. Say it this way, 125 thousandths. If you say it that way, it literally tells you what it is. A fraction. Every decimal is actually a fraction. It's just up to you, the reader, to actually read it as a fraction and not 0.125 because that doesn't tell you what it is, right? So it's 125 thousandths. Now I do insist that you simplify these. So that will be, let's see, 125. Let's see, that'll be 25 times 5. It's 125 is 25 times 5. And 1,000 is 25 times, how many? 40? All right, if you have to use a calculator to give you a little bit of a boost, I've already mentioned this. When numbers get into the hundreds and the thousandths, you can have that as a safety net. I'm going to try not to use it unless absolutely necessary. But I think a few of you noticed some of my mistakes caused by my overzealous, anti-use of calculators. And then I had to regret I should have used a calculator, or at least concede that I probably should have used a calculator. If you use a calculator on this too quickly, it'll just put you right back to here and you'll just be running around in circles. You'll never get the final answer. So it's not that I'm being mean by telling you not to use a calculator. It's that you can sit there and drive yourself crazy with your calculator and never actually get the right answer. Okay. One thing you can do is check with a calculator. That's something I always encourage. So 25 times 5 is 125. 25 times 40 is 1,000. If you don't believe me, you can check that on a calculator. And now you can cancel the 25s. Keep on going. 5 is going to be 1 times 5. 40 is going to be 8 times 5. And you want to cancel the 5s again. And so you're going to get 1/8. There are many, many, many ways to factor this. This is just the way I chose it in this moment. I did 25 and 5, and then I did, 8 and 5. You could have also done 4 and 10. That would have worked as well. All roads lead to 1/8. So no matter, don't want anybody to get hung up on how they're going to go. It's as if it's a map and every road should lead you to that destination. Or every proper road. Don't go, shortcutting it. Take a shortcut, you might end up lost somewhere. All right, so there we go. That's the technique. Over-explained probably, but that's okay. I'd rather over-explain than under-explain. So again, how do we read this? Most people read it as 1.4, right? I know I do sometimes, yeah. But I read it as 1.4, but then I stop and think, what does it actually mean? It doesn't mean 1.4, it means 14/10. That's what that means. Again, look back at example 1, the very first example I did today, right? That's 14/10. Right? And then now factor it. 7 times 2. Now be really careful. This is a decimal. This is a multiplication dot, and they are very easily mistaken for each other. 14 is 7 times 2. 10 is 5 times 2. This one doesn't have a lot of choices. That's your only choice for those numbers. And so the answer is 7/5. All right. These problems are very similar. In fact, I probably didn't need to do both of these. They're almost the same problem. So 2.2, that's 22/10. 22/10. 22 is 11 times 2. 10 is 5 times 2. And this is what I meant when I said these two problems are almost the same problem, just with slightly different numbers. This one becomes 11/5. Okay. And then the last one here, 0.85. Again, read it as a fraction, 85/100ths. And then break it down. 85 is 5 times... Well, let's think this out for a second. 5 goes into 40 8 times. So that means 5 goes into 80 16 times. So that means 5 goes into 85 17 times. And then we all know that 5 goes into 100 20 times because we learned that one and you use it all the time, right? There are 5 20s in 100 and there are 25s in 100. That's where we get things like nickels. Yeah, there are 20 nickels in a dollar because a nickel is 5 cents, yeah, or 1/20th. So this would be 17/20ths, also known as 17 nickels. Be careful when you memorize these because nickels are not fifths. Nickels are 20ths, yeah, a 5 cent piece. So 85 cents is 17 nickels. Yeah. Not 17/5ths, but 17/20ths. All right. So those first 5 examples were really to build the roadmap between decimals and fractions. And now we're going to combine the concepts together using the operations and at some point the order of operations. For now, I'm just going to start off with some basic operations. This is called evaluating. It's also called performing the operations. There's lots of ways I could say this. I could say calculate, I could say find, I could say determine, I could say evaluate. I'm basically just saying do the math. 6/7 plus 0.2. I will give, I'm not going to say probably, I will give instructions as to which form I want the answer in. So for this one, I want you to work with fractions. Now, there really is no, overarching law of mathematics that says when are you supposed to do something with a fraction and when are you supposed to do it with a decimal. That is really a personal choice. But I want you all to do each problem the same way so that we all get the same type of answer. That's one reason. But the other reason is sometimes fractions do not behave well as decimals, which we'll cover more of that very soon. So I've kind of pre-screened all the problems, and something with a very, very bad decimal expansion, so 6/7 if you ever tried it, maybe we'll try it later in this lesson. It's not the best. I mean, it depends how you look at it, but it's really long. It has lots of different decimals, and it's not something that you could easily just snap out in your head. So it's better to keep the one that's going to be misbehaving and just let that one be misbehaving, and then take the well-behaved one and change them. I know that doesn't seem fair. It's almost like we let the misbehaving number stay what it is, and then it's the well-behaved number that you're causing to change. So you're going to work with fractions. 2/10, you're going to write that as 2/10. All right. Now you want to simplify. So that'll be 1/5. Again, I did that with mental math. Maybe I'll just do a little bubble here. That's 2 times 1 and 2 times 5. Cross off the 2's, and that's how I got down here to 1/5 so quickly. And now you want to find an LCD. So the LCD is going to be 35. If you don't simplify, your LCD ends up being 70, which is not necessarily wrong. It's just too big. And we always want to get the smallest denominator that we can possibly get or have or work with. Think of it like it's costing you. Would you rather spend 70 or would you rather spend 35? You're always trying to be cheap and spend the least amount. So again, I'm not going to go through the whole lesson on how to do the LCD today. We're too far beyond that. That was chapter 4. So review chapter 4 if necessary. LCD is 35. You're going to multiply this one by 7. You're going to multiply this one by 5. So you're going to have 30 35ths plus 7 35ths. So you have 37 35ths. And that's your answer. Not much more to say about that. I wanted to pause for 1 second just to look at it to see if I could go any further. So I'll just put a little note, reduce if possible. Evaluate, work with fractions. What is it? I'm going to read the right problem. It's a 4/3 minus 0.8. All right, 4/3 minus 8/10. All right, so it says work with fractions. So I have 4/3 minus 8/10. Now again, 4/3, if you try to turn it into a decimal and then combine it with 8/10 and then try to switch it back, you usually end up being off by a little bit. That's because 4/3 is an infinite repeating decimal that we're going to talk about very soon. So I'm trying to make that very clear as to why I'm choosing this method. It's not because it's the only way. It's because it's the least resistance. It's going to cause me less suffering here. Okay, now I could do the LCD now. It would be 30. Okay? Or I can reduce it. 8/10 becomes 4/5. And again, mental math, that's 4 times 2, and then 5 times 2, and then you cancel the 2's. Okay, that's how this happened. And now my LCD is much smaller. It's only 15 now. So for an LCD of 15, I'm going to multiply this one by 5 and multiply this one by 3. So I get 20/15 minus 12/15, which is 8/15. And then again, if possible, reduce it. It is very, very rarely reducible, but you got to at least give it a look and see. You know, if that was 9/15, then it would have been possible, or if it was 10/15, but 8/15 is not reducible. Okay. Now, if a fraction is easily written as a decimal, and when I say easily, I mean it does not repeat, 333333333 or 666666666. As long as it doesn't repeat, or if it doesn't have like a very exhausting expansion where there's 10 or 12 digits in the expansion, we tend to use decimals in Chapter 5. I mean, that is the title of Chapter 5 is decimals. So in my next couple examples, I'm going to do basically the same thing, but in reverse order. I'm going to do it using decimals. So let's say evaluate with decimals. Using decimals. So now I'm going to rewrite the fraction as a decimal. And 1/4 is one we've talked about just in the last 20 minutes or so. 1/4 is a quarter, 0.25, 0.25. Now again, if you need to show some steps or you need to review quickly how to do that, then that's fine, but I just did it a few minutes ago, so I'm going to assume that we have a memory of that. Okay, and then remember when you're adding decimals, you have to line them up. So the 0.2 goes underneath the 0.25, lining up the decimals, and so you're going to get 0.45. Pens are really getting a workout today. They're starting to run out of ink. So, example 9. Oh, cool. I just left the instructions up there this time, so I don't have to rewrite them. How about 9/16 plus 3/100. 9/16 plus 3/100. Now 9/16 is not one that we've done in this lesson. It's not one that I typically memorize. Although if you spend any time in the auto shop or in any type of a mechanical environment where you're dealing with tools and things a lot, you probably are familiar with the 9/16. Right? It's a very common size. I honestly don't know that. It's just not something I memorized in my life. So we'll go ahead and figure that one out ourselves. All right. So 9/16 as a decimal. I'm going to do a little scratch work over here. because it seems like I have a little bit more room over here. So I've got 9 is the dividend. Be very careful. Dividend and divisor is 16. 16 does not go into 9, so put a 0. 16 does go into 90. How many times? How many times does 16 go into 90? 4? 5? 5. I was thinking 4 is too small, right? 4 would be give you up to like get you up to like 70 something or something. So 5 will get you all the way to 80. All right. 90 minus 80 is 10. Add another 0. Bring it down. 16 goes into 100. Well, look back. 16 went into 90 5 times, so it'll go into 100 6 times. You might have memorized this one. 16 times 6 is 96. 16 times 6 is 96. 100 minus 96 is 4. Bring down another 0. 16 goes into 40 twice. 2 times 16 is 32. Subtract, remainder 8. I was getting excited there. I thought we were done. One more. So remainder is 8. Bring down a 0. 16 goes into 80. Well, we've already done that one. 16 goes into 80 5 times, so we're done. 5 times 16 is 80, and you can stop now. All right, that's called terminating. So now I've got 0.5625 or 5,625 10,000ths plus 0.03. Stack them up. Make sure you line up the decimal points and you get 0.5. Well, we better do it right here. 5925. I really should have put some placeholders here and done it from left to right to be safe. I got lucky. There was no carrying, no borrowing, or any of that jazz. So there you go. There's your answer. 5,925 10,000ths. Okay, you could also get into negative numbers. We might have some negative numbers showing up, and we've kind of ignored them a little bit lately. They've been hanging around, but just kind of on the back burner, waiting to come back. So let's do this one. 1/10 minus 3/2. 1/10 minus 3/2. So 1/10 is already a decimal. 3/2 can be written very nicely as 1.5. Again, if you need a quick refresher on how to do that, you just go 2 goes into 3 one time. 1 times 2 is 2. Subtract. Put a decimal, bring down a 0. 2 goes into 10 5 times. You know what? I recommend you just memorize that one. 3/2 comes up so often, it's 1.5. And you get a remainder of 0, and you can stop now. All right, in the event of negative numbers, you just think of this as money. This is like having 10 cents, yeah, but you spent $1.50. Well, you know you're going to have $1.40 because you spent 10 cents out of $1.50. But you didn't have $1.50. You only had 10 cents. And so that means you are overdrawn. You are in the negatives, negative 1.4. Remember, keep the sign of whoever has the larger magnitude or the larger absolute value. Okay, that's the basic operations. Now we're going to combine them together and use the order of operations. Now I don't really have to say that order of operations anymore, so it's kind of considered unwritten law. So what I'm going to say instead is perform the operations. So I kind of give you a clue that I'm using the order of operations, but it is understood in mathematics, you know, once you've been informed of the order, that you have to follow the order. If there is no instruction, assume that I want... Actually, I'm going to take that back. I will always give you an instruction. I was about to say assume I want a fraction, but that is not a safe assumption in a chapter that's called decimals. So I'll say perform the operations, and then I'll tell you how to give the answer. Give the answer as a fraction. If that's what I want. If I want a decimal, I have to tell you. Maybe in some other classes that there would be a basic assumption of fractions unless otherwise told. That's very common as well. If I don't say anything, assume it's a fraction. That's probably not a bad assumption, but you really should just read the directions. I can't tell you how many times I've done a problem and then gone back and go, oh man, I didn't read it carefully, and I wish I had read it carefully. So the order of operations, first we're going to, this only has two different operations. First we're going to multiply, and then we're going to add. It says give the answer as a fraction. That's more than just advice. That's sort of the law of this problem. So we're going to have 7/10 times 2/7. Remember, with fractions, you do not need LCDs. Excuse me, with multiplying, you do not need LCDs. You definitely need LCDs in fractions. When you're multiplying, we often just draw these arrows that go straight across, and you do not need to find an LCD. If you do, it oftentimes makes the problem worse. You should simplify, though, so let's cancel these 7s. And then if you have a whole number, every whole number has an invisible denominator of 1. So we have 2/10 plus, and we're going to multiply this one by 10 and write it as 60/10. You must have an LCD when you're adding. So I didn't need the LCD back here in the multiplication part, but I do need it now in the adding part. So finally, I'm going to get 62/10. And I said this earlier, if possible, you want to reduce that. It's possible, right? It's 31 times 2 and 5 times 2. Crossing off the 2's. Give the answer as a fraction. So the answer is 31/5. Don't give me a decimal if I don't ask for it. Don't give me a mixed number unless I ask for it. Just give me a fraction. Let's do the same type of problem, but this time as decimals. And I'll ask you to round if necessary. Let's do the most common rounding in my class, and not just my class, but a lot of these math classes, is hundredth. Mainly because of money. We're going to do a whole module on money very soon, if we haven't already discussed money. When you translate a word problem into dollars and cents, you often round to the nearest hundredth. So we'll come back to that. So when I said the same problem, I mean something that sort of looks the same. Let's try, meaning it has the same feeling. So we got 12, negative 12 times 4/9 plus 3/10. So it has the same sort of flavor. This one just, I'm going to do the whole thing using decimals. Okay, now a couple things I want to point out. One is read carefully, which I've already mentioned that. The other is that if you are multiplying a fraction and an integer, the denominator is an invisible 1. I think I mentioned that in the last problem as well. In fact, it doesn't matter that you're multiplying. Anytime you see an integer or a whole number, there's an invisible 1 on the bottom. That's really meant to keep you from doing this. I can't tell you how many times I've seen this happen. You write the 12 or negative 12 very sloppily or very quickly, which I'm also guilty of, and then you go 12 times 9. And then the rest of your problem is just a waste of time at that point. You will never, ever get the right answer if you do that. So you see a whole number or an integer and you're not quite sure where it is, it's always on top, and there's an invisible 1 on the bottom. And so that means you can just multiply straight across, and you're going to get negative 48 over 9. Now I want to turn this into a decimal. Yeah. I'm going to turn this into a decimal, but watch how I do it. All right. I'm not going to do it quite yet. Hold off as long as you possibly can. And then when you just go, all right, fine, I'm going to switch over to decimals. Try to avoid them as long as you possibly can. So 48 is actually 18 times 3, isn't it? Or 16 times 3? 16 times 3. Negative 48 is negative 16 times 3. And 9 is 3 times 3. So I'm sure glad I didn't turn that into a decimal now. I could have made my life a lot easier by factoring out the 3's. And now I'm finally going to relent. Okay, I've got negative 16/3 plus 3/10. Let me just, I don't have room to write that, so I'm just going to put it right here. Negative 16/3 using decimals. Here's my scratch work. All right, ignore the negative for now. You can't put a negative sign in your division sign. So just make that a 16, make that a 3, and just do your long division. Three goes into 16 5 times. 5 times 3 is 15. Subtract. Remainder 1, bring down a 0. 3 goes into 10 3 times. 3 times 3 is 9. Put a remainder 1, bring down another 0. Oh, no, look. You saw this once before, didn't you? I remember when I was in 4th grade and the teacher didn't want us to talk or wanted to keep us busy for an hour. My teacher would give us this division problem that just goes on and on and on and on and on and on forever and ever and ever and ever. And so this is a repeating decimal. Yeah. So go at least one space further than what the instructions say. So the instructions say 100th. I'm going to go one more than that. So I'm going to go to 1,000th. Now, why do you do one more than the instructions? Why not just follow the instructions? Because if you follow the instructions as you're solving the problem, you'll end up one short of where you want to be at the end. All right? You always want to aim big, go one bigger than what you're being asked for, and then you can back up to the proper spot that you need to be at. All right? So now put my negative back. So I've got negative 5.333. You can actually go more than that, but that's the minimum amount. Plus 0.3, 0.3. Now I'm going to need to stack these things, but I'm running out of room. Here, this is taking up a lot of room up here. So let's just get rid of that. So let's come all the way back up here. So I've got sort of just kind of moving this all the way around here. Cut away. Negative 5.333. All right, plus 0.3 or 3/10. So I'm going to need to use negative numbers here. All right, this is like having 30 cents in the bank, but then going and spending $5.33 on lunch. You're going to end up overdrawn. So let's reverse it. Let's do 5.333 minus 0.3. Put a couple placeholders in here. And we're going to get 3. 3 minus 0 is 3. 3. 0. And then 5 minus 0 is 5. But remember, the 5 is larger in absolute value than 3/10. So your final answer is bring the negative down, negative 5.03. And now you can do the rounding. All right, this is your round dictator. So we're going to round down by simply throwing that away. All right, so that is your final answer, negative 5.03. All right, that was a long one. That one took a lot of technical details. I will make just a couple comments before I erase all of this. Another technique that you might want to try on your own if you find that you like some variety is try turning the 3/10 into a fraction, 3/10. Honestly, I wish I would have done it that way because we would have been done a little bit sooner and I would have still gotten the same result. All right. The only price that you pay for doing that is when you're done, your answer will be a fraction, and then you have to do the long division at the very end. I snuck the long division in, and then I went to my negative 5.03 as the final answer at the end. But either way you slice it, it should all be the same result. I think I'm up to 13. I don't know. I have a really bad habit of losing count, but I don't feel bad because, you know, when I was in school, my teachers never numbered any of the examples. It was just, here's an example. Oh, here's another example. Well, here's another example. So in this internet environment, I like to number things because you might be rewinding and fast forwarding and things like that, so you can know what problem am I trying to look at, you know. So occasionally I'll get off track, but that's okay. Forgive me. Let's try another one. Let's do another one with decimals. So evaluate. Actually, I don't want to say that. It means the same thing, but I want to say it the way it's going to be said. Perform the operations. This is another way of saying calculate or evaluate or determine or find, or you know, us math people, we got to have like 10 words for every concept. So perform the operations, give the result as a decimal. Let's say round to the nearest hundredth. If necessary. If it's not necessary, I'll ignore the rounding part. Sometimes it's not necessary. So you got negative 5. Square bracket means the same thing as a parenthesis. 8/7 minus 7/10 squared. If you prefer just using all round parentheses and when you're writing, you certainly are allowed to do that. We do this to sort of break up the monotony of seeing a lot of different parentheses, but these mean the same thing. Okay. So what I'm going to do this time, because I think last time I made a comment about it, but I didn't actually do it that way, I'm going to do the whole thing as a fraction, and then I'm going to give the result as a decimal. In other words, I'm going to wait until the very end to do the long division. Now, if you don't want to do it that way, you want to try by turning it into a decimal now, it's good luck. It'll probably work out, yeah. And if you are sneaking a little calculator work here and there, I won't know that you're doing it, but you know you're doing it. I also wish you the best of luck with that. All right. You might be causing more harm than good. All right. Another thing I want to mention is when you have a multiplication or some sort of operation outside of the brackets, you should also wait on that. So make that 5 wait outside here. If you're really impatient, you can try to put it in now, but it's usually not a good idea. So 8/7 minus 7/10 squared. Now be careful, the negative is outside, so don't square the negative. That old, negative times a negative is a positive thing really comes back to haunt you sometimes. So I've got 8/7 minus 7/10 squared. Again, I'm making this -5 wait outside for me. So I'll be right with you, -5, just you're on hold. I've got 8/7 minus 49/100. Yeah. When you square a fraction, you square both the numerator and the denominator. So 7 times 7 becomes 49, and 10 times 10 becomes 100. So you're applying the square to both the top and the bottom. Okay, what's my LCD going to be? 700. 700 is my LCD. Unless I want to put the 5 in and make it complicated. I think I'm just going to leave the 5 out because I said I was going to do that. Moving over here so that the -5 stays out. I'm going to multiply this one by 100. So I end up with 800/700ths. And then I'm going to multiply this one by 7. I don't know if you can see that, but hopefully you can see it now. Move it up a little bit. So 100 times 7, that's mental math, 700. 49 times 7. I haven't done it all hour long. You've been sitting through this lecture. I'm finally going to show you that I'm a person just like you. And sometimes when I get a big number that I don't feel like doing, I'll do it with my calculator, 343. I do feel a little silly because I already knew it was 343. The little ghost of the past was going, it's 343. But I just wasn't sure. And I didn't want to proudly proclaim that I knew it was 343 when I wasn't absolutely sure it was 343. But now I know. So my calculator helped me that time. All right, less is more when it comes to these calculator problems. I am totally out of room here, so we're going to come all the way back up here to the top. So I've got -5 times, let me just copy the whole thing so we don't lose any of it. 700, 800 over 700. 343 over 700. Again, this -5 is just waiting. Anybody in this class that survived an algebra class in high school or maybe in college many years ago or maybe just last semester, I don't know, you might be going, Dr. Jordan, why aren't you using the distributive property? It's because I haven't taught the distributive property in this class. So, I mean, if you do have a remnant of an old algebra class that's making you want to put that -5 in, go right ahead. That's fine. You can get ahead of me if you want a little bit, but I'm doing it in the order in which that I've taught it. So 800 minus 343, I'm also going to use the calculator for that. So that's 457. It's not negative yet. It's still positive. It will be negative at the end when I multiply by 5. And then finally, my last step, or maybe it's my second to last step, is to put this invisible 1 so that I don't accidentally multiply 5 times 700. That would ruin this whole adventure that we've been on. Like making it all the way there and then crashing right as you pull in. Okay, so just keep that straight. So now you've got -5 times 457. I'm getting rid of the parentheses now. Some people call these brackets. They're just another form of parenthesis. And then 1 times 700 is just 700. Okay, and then finally, -5 is, I guess that's -1 times 5 and 457. I'm just factoring it out completely. 700 is 5 times 140. And I can cancel the 5s. So now I've got -457 over 140. Now I'm going to follow the directions. Now, follow the directions. And give answer as a decimal. I realize I'm going on over an hour now, and I'm only halfway through. Well, I'm a little bit more than halfway, but so for the sake of time, I'm going to do this only because of time. I'm going to go ahead and I got my calculator out. 457 divided by 140. And you'll see why right now when I write it down, why I made a very wise choice. Don't forget the negative. So it's -3.2642857. If I would have done long division, we would be here probably for another 10 minutes. I am going to discuss these types of decimals in part 2 of this lesson, but we're not going to have time to talk about them today. So I did that with my calculator. I know that they exist. Calculators exist, so I had to use it. Now follow the directions. Nearest hundredth. So we got 10th, 100th. Dictator is a 4. That's less than 5, so we're going to throw away all the decimals, essentially making them all zeros. Some people call that zeroing it out. And if this were money, it would be I owe $3.25. It's -326, 3.26. I only have time for maybe one more. So what do we got? One more of these, and I think we'll have to put this to bed for now and come back tomorrow. Example 14. Or am I up to 15 now? I don't know. I've lost track. Is it 15? It's a little voice in my head saying 15. Whatever it is, it's the last example for today. All right. So, what does this one say? Perform the operations, give the result as a fraction. Nice. I like to end with that. perform operations, give the result as a simplified fraction. So in the last example, I taught, or I at least emphasized, the whole wait principle, right? Waiting until the very end to do any operations that are outside of the brackets or the parentheses. That was more than just a piece of advice. That was really kind of leading up to this very problem. I do this in practically all my classes. If you see something easy, something very easy like this, 8 plus 0.9, which you could probably just do it in your head, you get 8.9, it's not correct, all right? That does not follow the order of operations. This is what I call bait. In my class, when I put a very simple expression or a very simple operation at the front of a problem, it's too good to be true. It's like somebody dangling it right there going, come on, go for it, take a bite. It looks good, doesn't it? It looks easy, right? And I know it's psychological. Most people go for the bait, and that's why I keep doing it. Right? And as long as it keeps working, I'm not going to change the bait, you know? So don't do it, all right? Wait. Yeah, don't do it. Ever. Yeah, follow the order of operations. All right, the order of operations, which I'm really never going to tell you anymore. I'm going to assume that you've been trained in the order, and so now you have to follow the order. All right. So what we're going to do is we're going to do all of this first. Yeah, this first. So I'm going to wait. I've got 8. And my pen is barely going to make it through this lesson. I might as well rewrite this as a fraction while I'm at it. 9/10. Yeah, 9/10. And by the way, that I'm not actually doing the addition. I'm just rewriting 9/10 now so that that's done. That's going to be 7 over 1. Yeah, there's an invisible 1. And then I'm going to do the exponents. That'll be 1 over 25. So do that first. Yeah, 1 times 1 is 1, and 5 times 5 is 25. Now I'm going to do my LCD, which is 25. I think I got to switch to green because this pen is dying on me. So I got 8 plus 9/10. 20. Sorry, I don't know what 25 times 7 is offhand. I'm going to guess 175. Seven times 25 is 175. If you're not sure, you know, I've made these mistakes before. I'd much rather be right than have to put my disclaimer on my YouTube channel saying there was a mistake. Okay, and now I'm going to subtract. Oh, where am I going to go with this? I guess I'll just go up here. I got 8 plus 9/10 times... subtract these guys. That's 174 25ths. Now I can just go straight across. Yeah, remember brackets are the same as parentheses. So 174 times 9. Notice I'm waiting to do the plus 8. That'll be the very last thing I do is add this plus 8 that's been waiting very patiently. I get 1,566 or 1,566 over 250. The 8 actually has an invisible 1 underneath it. Let's see if we can reduce this a little bit. This is divisible by 2. So this is 8 over 1 plus, how did I know it was divisible by 2? Well, it's even. Yeah, so it ends in an even number, so it's divisible by 2. Now, why would I want to do that? Because I want my least common denominator to be the smallest I can possibly get away with. That's my LCD. So now I've got a better LCD, which is 125. If you can go further, if you can reduce more, then do it as much as you possibly can. Looks like my LCD will be 125, so I have to multiply the 8 by 125, top and bottom. So now I have 8 times 125, which is 1,000. I should have known that. Plus 783 over 125. And finally, the lesson that never ends is finally over. 1,000 over 125 plus 783 over 125 is 1,783 over 125. And I'm just going to box it because I'm about 99.9% sure that it's irreducible, that they don't have anything in common. You never know what you're going to get, though, so you should take a look at it. If they both are divisible by 5, well, then you can reduce it. If they're both even, divisible by 2, you can reduce it. You know, there's various scenarios in which this could possibly be reducible, but today, this example is not one of them. There is going to be a part 2 for this lecture, but until then, this is Dr. Jordan. I'll see you on the internet.